So today we are solving systems of equations using substitution. You're going to whine. You're going to tell me it's way too much work. You're going to tell me it takes way too much paper. But once you learn it, once you figure out how to do it, you're going to like it more than graphing. It's actually about the same amount of work. You do have to show a little bit more work with this, but you know, I think it's easier. We'll see what you think. All right. Our first system that we're going to look at is y equals 3x minus 7 and 2y plus 6x equals 10. So that's our first system. We're going to see what the answer to this system is. All right, so first step is to isolate a variable. In this case, we already have a variable isolated. And by isolate a variable, I mean get a variable alone, completely alone on one side of the equal sign. We have that. We have y equals 3x minus 7. That is our variable that is alone. I know that y equals all of that. Okay? So I can take all of that and I can substitute it in for y in the other equation. Our next step is to substitute and solve. We're going to start way up here because there's not very much space down here. All right, so we have 2y, and y equals all of this, 3x minus 7, plus 6x equals 10. Very important. When you are substituting and solving, you have to substitute the isolated variable, whatever the isolated variable is, into the other equation. Otherwise, everything's going to zero out, and you're going to think your answer is 0. It is not. You got to substitute into the other equation, which is why I substituted all of this from this equation into this one. Okay, so the next thing we do is we distribute. 2 times 3x is 6x. 2 times negative 7 is negative 14. Then we have plus 6x equals 10. We combine our like terms. 6x and 6x is 12x. Minus 14 equals 10. Add 14 to both sides, and we get 12x equals 24. Divide by 12, and we get x equals 2. So we know that our solution, x is going to be 2. We're going to take that 2 and we are going to substitute it into one of these equations. Does not matter which one, as long as it's being substituted in for x, because it's what x equals. If it was what y equals, we would be substituting in for y. But in this case, we're substituting in for x. Doesn't matter which equation. So y equals 3x, but x equals 2, minus 7. All right, so 3 times 2 is 6. 6 minus 7 equals negative 1. So our solution to this system is 2, negative 1. Let's try another system. All right, let's go with negative 2 equals 2y minus 4x and y equals 5x. That does not look like a 5. Come back. There it is. Y equals 5x plus 5. All right. We already have a variable isolated. We have y equals 5x plus 5. We can take this, that y equals, and substitute it into the other equation. It must be into the other equation. So we have negative 2 equals, we're looking up here, 2y, and y equals all of this. 5x plus 5 minus 4x. Okay, so we're going to distribute on this side of the equation. We have 2x. Distribute this 2. 2 times 5x equals 10x. 2 times 5 equals 10. And subtract 4x. Combine our like terms. We have negative 2 equals 6x plus 10. Subtract 10. We get negative 12 equals 6x. divide by 6, and you get x equals -2. So we know that in our solution, our x value is going to be -2. I take that x value and I substitute into either one of the equations. So we have y equals 5 times -2, because x is -2, plus 5. 5 times -2 is -10. -10 plus 5 equals -5. So our solution to this problem, to this system, is going to be -2, -5. If we were to graph these two lines right here, they would meet at -2, -5. All right, I want you to take this system home. Y equals -2x plus 4, and 4x plus 4y equals 20. I want you to take that system, work with it, try it, bring it back to class tomorrow. We will talk about it tomorrow. And let's see, our code word, our magic word that you're going to email to me is going to be, go Broncos.